Myself, Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about the input-output subsystem organization and interfacing. At the end of this video, the student will learn about the functionality of the input-output unit in the computer system and what are various input-output devices and how they are interfacing with the CPU and the memory, and some problems related to the input-output subsystem organization. The basic agenda of this video is introduction. What are the input-output devices that are available? Next, the input-output interface, modes of transfer, and direct memory access. From the functional units of the computer, there are majorly three basic units in the computer: the input unit, CPU, and the output unit. The input unit provides the man-to-machine interaction. The user can supply the programs to the system to perform some functionality. In order to produce the required functionality, the system can require some data. That data can be supplied with the help of input devices. And after computation or processing, the system can produce the information. That information can be represented in a user understandable form with the help of output devices. So, man-to-machine interaction is provided by the input unit and machine-to-man interaction is provided by the output unit. A variety of input-output devices are available. Depending upon the user application requirement, one or more input-output devices can be connected to the CPU. The input plays the major important role during the program execution. There is a basic principle in order to provide an functionality through an application is GIGO. GIGO. If the user supplies garbage as an input to the program, then the user can get garbage as the output. Which means if user gives an incorrect input to the program, the user can receive incorrect output. The intended functionality of the program should not satisfy if user gives incorrect or garbage as the input. In the programming, we are having majorly two categories of errors: syntax errors and semantic errors. Each programming language can follow certain rules that can be framed with the syntax. If the user wants to use some particular construct of the high-level programming language in the programs, then he has to follow certain rules that are specified by particular programming language. So, those rules are violated, then the compiler can recognize it during compilation process and those can be displayed as errors. Those syntax errors can be easily detected. But the semantic errors comes under the logic errors. But in case of the logic is correct and if you produce incorrect input during program execution, the functionality can be correct, but the output can be incorrect. So those these errors can be very complex to the user to detect and to debug also. So that's why more care has to be taken while giving the correct input during the program execution. The input operation can be facilitated with variety of input devices. how these devices can be connected to the CPU or memory, what is the various interfaces available, and what is the communication channel that is available for these input-output interfaces, and how direct memory access can be possible with DMA, that we have to discuss in this video. So input unit provides man-to-machine communication. So the user has to supply the required data for the processing with the help of the input device. So here input unit accepts data in human readable form and converts into the machine readable form with the help of interface and supplies it to the CPU for the processing. The output unit is provided for machine to man communication. After processing, information produced from the computer can be presented in user understandable form with the help of output devices. That's why the output unit provides machine to man communication. It receives information from CPU in machine readable form and it can present it to the user in a desired form or user understandable form. The I/O subsystem of computer provides an efficient mode of communication between the central system and the outside environment. So here the user interaction has to be possible with the input-output devices only. So the CPU or the computer can have interaction with the external environment by using these input-output devices. What is input-output subsystem? The I/O subsystem of a computer provides an efficient mode of communication. So major mode of communication can be facilitated by the user with the computer by using the input-output devices. So from the central part of the system CPU and the outside environment, the communication can be possible with the input-output subsystem. It handles input-output operations of the computer. So if you consider any high-level programming language, certain set of input-output operations or statements are available in the each and every programming language. By using these statements, the input-output devices can be activated and the needed data for smooth program execution can be supplied with the help of this input-output subsystem. The input-output devices, the another term are most frequently used, that is the peripheral devices. So input-output devices that are connected to the computer are called the peripheral devices. So the input devices and the output devices, both categories are combinedly called it as peripheral devices. These devices are designed to read information into and out of the memory unit upon the commands from the CPU. Depending upon the command issued from the CPU, by using these devices, the read and write operations on the memory can be performed. And these devices are called the peripheral devices. Example, keyboard, VDU, display units, printers, all these are various peripheral devices. How these peripheral devices are connected. So here we are having keyboard, mouse. Not only these two varieties are available. In the earlier videos, we discussed various input devices. So here the devices that are available are MICR, OCR, OMR, joystick. All these are varieties of the input devices. So depending upon the user application, one or more input-output devices can be connected to the computer. So here keyboard, mouse, you can use any other input device like MICR, OCR, and these devices can be connected to the memory, which in turn exchange the information and perform read and write operation depending upon the CPU signals, control signals that are produced, and the exchange of information can be carried out to and from memory to the input-output devices. So here, by using the input devices, the data can be supplied, and after that, by using this, the CPU can be perform the processing activity. After processing, the processed data generally referred as information. Whatever information produced from the CPU, that can be represented via the output devices. Variety of output devices can be available: monitor, printer, speaker, and all these are the variety of output devices. So here, from the input devices, for execution of command or program, whatever needed data that can be supplied via the input devices, and with the help of the control signals that are generated from the CPU, the read and write operations can be performed on the memory, and processing can be done. And after processing, the information produced from the CPU can be represented in a user understandable form by using variety of output devices. The peripheral devices are categorized into majorly three types. One is input peripherals, second category is output peripheral, third category is input output peripheral. So input peripherals allow only the input from the outside world to the computer. So the data that is required for the CPU can be supplied by using these input peripherals. So example of input peripherals are keyboard, mouse, etc. So these are generally the category of input devices. Next is output peripherals. Allow information from the CPU and can be represented to the user or the outside world. And here the examples of output peripherals are printer, monitor, etc. But some devices can be used for both the purpose. That is, these peripheral devices can be used as input, or it can be, same device can be used as served as the output. So those peripheral devices can be called input-output peripherals. So allow both input as well as output by using these devices. The example of input-output peripheral is touch screen. So with a touch screen, the user can able to give the input and he can visualize there itself the output. So the device touch screen comes under the category of input-output peripheral. So here various types of peripherals that can be pictorially represented. So all these devices comes under the input category. So here light pen, keyboard, mouse, all these are there, touch screen, modems, all these are there. So the intersection of these devices can be used for both input as well as output. So these are the input-output peripherals. This category is belonging to the input peripherals, and here the VDU, the LCD, speakers, headphones all comes under the output peripherals. The common which devices can be served for both input-output devices can be under the intersection section. So those can be served as for the two purposes. That's why those peripherals called input-output peripherals. Now for each and every device, peripheral device that is connected to the system can require an interface. Now we have to discuss about what is an interface. Interface is a shared boundary between two separate components of the computer system. So here we are having the memory CPU, the internal parts of the CPU, and the input devices. So here there should be a clear boundary that can be shared the data or information, which can facilitate the exchange of information. So here interface is a shared boundary between two separate components of the computer system, which can be used to attach two or more components to the system for communication purpose. So here variety of input output devices can be connected to the computer depending upon the application requirement. So these devices can be connected and can be having a clear boundary with the central part of the computer, and this boundary can be facilitate the sharing of data or information between these two or more separate components. That's why the term is called the interface. There are two types of interfaces, CPU interface and IO interface. The input-output system can majorly connected with the IO interface. So you have to concentrate what is input-output interface. The input-output interface, peripherals are connected to a computer need special communication link for interfacing with the CPU. So the devices that are connected can have a special communication channel with the CPU. So what is a channel? That we have to discuss. In computer system, there are special hardware components between the CPU and the peripherals to control and manage the input-output transfers. So these components are called input-output interface units. So with the help of interface unit, the input-output devices can facilitate the communication between the CPU and the external world. So the communication channel that has to be link the CPU with the input-output devices is the processor bus. They provide the method for transferring information between internal system and the input-output devices. Now pictorially we have to see how the interface can be connected. So here the example we considered the input-output devices, monitor, keyboard, hard disk. So here these devices can be connected with the interface. This is the input-output interface. Each device is connected with the interface. And here these interfaces can be connected with the system bus. The system bus can have three varieties of bus. So here address bus, data bus, control bus. All together is referred as system bus. So this interface can the monitor, the input-output devices are connected with the interface. The interface can link these devices with the CPU, central part of the computer, with the bus. So the bus can establish the communication link between the central part of the system and the outside world. So here this is the CPU and memory, and input-output devices can be connected with the system bus. Why this interface is needed? Because of majorly four reasons. Peripheral devices are electromechanical or electromagnetic devices. That means all input-output devices are generally the electromechanical or electromagnetic devices. But computer is an electronic device. So there is a conversion of signal values can be required. So this has to be solved with the help of interface. And the data transfer rate of peripheral is usually slower. The rate of data transfer of input-output device is slow when compared to the CPU. So to synchronize these speeds, data transfer rates, synchronization mechanism is needed. That synchronization is done with the help of the interface. The third reason of using need for interface is data codes and formats in peripheral differ from the word format in the CPU and memory. So here the data codes that can be used as in the input-output device for data exchange that can be different from the CPU or memory word representation. So generally the input-output devices can be used as key codes for the data. So here in the word format, memory word representation can be different from these codes. So there is a need a interface. The operating modes of peripherals are differ from each other and each must control, so do not disturb the operations of other peripherals connected to the CPU. So for these reasons, the interface is required. So in the real world also, the user can experience this. Whenever a new device is purchased, a camera or a printer is purchased, and if the user link or connect this with the computer, then the user need to install a specific driver program pertaining for that device. So which establish the interface mechanism in order to compensate these four mismatches between the input-output device and the CPU. So to resolve these issues, the interface is needed and can be placed between the input-output devices and between the CPU. So the interface for each and every individual input-output device can be required. One example interface we can discuss here. So here timing and control signals. With these control signals, the read and write operations has to be facilitated. This is the CPU part and this is the IO device part. So these parts can have a shared boundary. This boundary has to be defined designed by the internal bus. So here port A, port B, control register, status register, 4 registers are there, and these registers, top 2 registers are used for input output data, and these control register are used to check the control signals. Status register is used to check the completion of input output process. So here for these 4 registers, to select the register selection lines can be used, and this is for chip selection line. So here whatever data that is given as input output must be stored in the buffer. With this buffer, depending upon the control signal that is generated by the timing and control signal, the read and write operation can be performed. So like this, the interface can be used between the input-output devices and the CPU. So here a channel has to be required. A channel is an independent hardware component that coordinate all I/O to a set of controller. So here computer system that use I/O channel have special hardware components that handle all I/O operations. Channels are separate, independent and low-cost processors for its functioning, which are called the channel processors. So here to coordinate all these I/O devices, these channels has to be used. The channel format, instruction format can be the processor, the small processors has to be used in the channels, channel processors, and the instruction format for this is the opcode, the channel address and the device address, which device can be actively involved in the transfer of the input-output operation. What are the various categories of input-output channels? There are 3 categories. One is multiplexer, second one is selector, third one is block multiplexer. A multiplexer channel can be used to connect a number of slow and medium speed devices. It is capable of operating number of I/O devices simultaneously. Multiplexer can be capable of holding and controlling and monitor a slow and medium speed uh, input-output devices simultaneously. The selector is the channel that can handle only one particular I/O operation at a time. But the devices that are connected with the selector is a high-speed device. The block multiplexer combines the features of both multiplexer and the selector channel. So these are the three categories of the input-output channel. So how the data transfer can be taken place? The internal operations of an individual unit of the digital system are synchronized with the clock pulses. The clock signals that are generated, with these only the operations of the devices has to be synchronized. In the example interface also, here the timing and control chip has to be generate the clock signals. With this, the devices operations has to be controlled. If the registers and the I/O devices share the common clock with the CPU registers. Okay, the CPU registers and the I/O interfaces can share the common clock of the CPU. Then that type of data transfer between the two units is generally referred as synchronous data transfer. So here, the same clock has to be shared between the CPU registers and the input-output interfaces. That mode of data transfer is called the synchronous transfer. If the I/O devices and the CPU registers can use the different clock signals, that mode of data transfer is called as asynchronous data transfer. So two methods of data transfer are there, synchronous and asynchronous. In the synchronous, the same clock has to be used between CPU registers and the I/O interfaces. But in case of asynchronous, different clock pulses can be used. And there are three varieties of data transfer can be take place. The mode of data transfer is programmed I/O, interrupt I/O, DMA. Programmed I/O means with the help of software and by checking the status of the status register, the data transfer operation can be controlled. That type of data transfer is called the programmed I/O. In case of interrupt I/O, with the help of interrupt signals and by describing the priority of the interrupt, the I/O operation has to be performed. So that category of data transfer is called the interrupt I/O. In case of direct memory access, instead of avoiding the CPU between the data transfer, directly the input-output devices can involve the transfer of the information. So these are the three mode of data transfer. How DMA has to be used. So here all I/O devices can be controlled with the DMA. So here it has to avoid the exchange of information here, but it can gain the CPU control with the two control lines. Those control lines are bus request and bus grant. Whenever needed the data transfer directly, then the bus request signal can be generated to the CPU so that the CPU can grant permission to exchange the data transfer directly between the I/O devices and the memory. So with the help of these two signals, the direct memory access can be done. So here three types of data transfer. Programmed I/O is based on the status register with the software. The data transfer can be facilitated. with the interrupt signals, and by deciding the interrupt priority, data transfer can be facilitated in case of interrupt IO. And in the third case, with the special signals, bus request and bus grant, directly the exchange of data between the input output devices and the memory can be taken place with the help of DMA. So these are the three modes of data transfer. So with this, we discussed about what are various input output devices, why they are needed for the program execution, and how the with the external environment the interaction can be provided with the peripheral devices. What are interfaces? What is various varieties of interfaces? What is a channel and what are varieties of channels? And what is data transfer and what are the various modes of data transfer we discussed. Now we will discuss about what are the critical thinking questions related to the input output organization. So here the bus which is used to transfer data from main memory to the peripheral devices. So here while performing read and write operation, which bus is used to carry the data is the data bus. Next, which of the following system bus is used to designate the source or destination of the data on the bus itself? The data bus holds the data to be read or write, but the address bus holds at which location of the memory this data has to be written. So that's why the source and destination has to be designated by the address bus. Next, how many memory locations of a system with a 32-bit address bus can address? So address bus can have 32 bit. So what is the how many maximum addressable locations of the memory? So 32 bits are there. 2 power 32 memory locations can be addressed by 32-bit address bus. Next, how many bits can be transmitted at a time using a bus with 32 data lines? Data bus can contain the 32 data lines. So 32 bits can be transmitted at a time. So a number of bits in the address line can be used to assess the memory location. Addressable memory location is 2 power 32. But if the data lines contain 32, so 32 bit of transfer of data can be possible at a time. Next, a microprocessor has a data bus with 64 lines and an address bus with 32 lines. So data bus is of 64 lines and address bus is 32 lines. The maximum number of bits that can be stored in the memory is, what is the storage capacity of the memory? So the amount of block that could be located is 2 power 32. Why? Because address bus contains the 32 lines. So 2 power 32 locations has to be addressable with the 32 lines of address bus. Since data bus has 64 lines, each block is of 64 bits. So the memory capacity can be designated with 2 power 32 by 64 bits. Next, the address bus with a RAM of size 1024 by 8 bits is. So the size of RAM is 1024 by 8. So 1024 is equivalent to 2 power 10. So 10 address lines can be needed to designate the locations of the memory, and here by 8 data lines can be needed, the word width. Okay, so here 10 address lines and 8 data lines is the answer. So Here we discussed about the input-output subsystem and interfacing, how the input-output processor can has to be used to mitigate various problems during the communication, and what are various channels, and what are the various questions related to the input-output organization. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.